In this question, we are told that the active ingredient in laundry bleach, NaClO, is synthesized by using 2NaOH plus Cl2 to form NaCl and NaClO as well as H2O. The question asks, what is the theoretical yield of NaClO from a mixture of 75 grams NaOH and 50 grams Cl2? So first of all, what is theoretical yield? Theoretical yield means the expected mass of a product. So basically this question is asking what is the expected mass of NaClO that will be formed from this mixture of 75 gram NaOH and 50 grams Cl2. Now this question doesn't state whether there's any limiting reactant, so we cannot make any assumptions here. We have to check. So to check whether there is any limiting reactant, we first have to find the moles of each reactant, NaOH and Cl2. We are given the mass in grams, so we can find the number of moles by taking mass divided by mR. So we get 1.875 moles of NaOH and 0.7052 moles of Cl2. Now let's take a look at the stoichiometric ratio in the chemical equation. So we see that 2 NaOH reacts with 1 Cl2. So the stoichiometric ratio of NaOH to Cl2 is 2:1. Now let's compare the moles of NaOH and Cl2 that we have with the stoichiometric ratio. Again, we can start from either reactant. So for this example, let's start with NaOH. So let's just first write down that stoichiometric ratio of NaOH to Cl2 is 2:1. And let's try to calculate how many moles of Cl2 would be required to react with 1.875 moles of NaOH. So based on the stoichiometric ratio of 2:1, the number of moles of Cl2 would be 1.875 divided by 2 equals to 0.9375 moles of Cl2. Now let's compare the number of moles of Cl2 needed with the amount of Cl2 that we actually have. We see that actually we have less than the amount of Cl2 required to fully react with all the NaOH. So we see that Cl2 is the limiting reactant, whereas NaOH would be in excess. So why did we need to find out this information of which is the limiting reactant? We actually need this information for the next step, which is to calculate the theoretical yield of NaClO. Remember that the amount of product formed is always dependent on the amount of limiting reactant present. So now let's take a look at the stoichiometric ratio between the limiting reactant Cl2 and the product NaClO. From the chemical reaction, we see that 1 mole of Cl2, the limiting reactant, gives rise to 1 mole of NaClO. So the stoichiometric ratio is 1:1. Since the stoichiometric ratio is 1:1, then the number of moles of NaClO would be equals to the moles of Cl2. So let's write that down. Moles of NaClO equals to moles of Cl2, which would be 0.7052 moles. So now that we know the number of moles, we can calculate the expected mass of NaClO. So mass of NaClO would be equal to the moles times mR. And we will get the answer 52.5 grams. At this point, since this is actually an intermediate step, it's not the final answer because there's still part B to do. You can leave more number of significant figures, but if you want to, you can also round it to 2 significant figures now. It might give you a slightly different answer in part B, but any slight difference that's just due to rounding is acceptable. Now in part B, you are given that the actual yield of NaClO is 43.2 grams, and you are asked to calculate the percent yield of NaClO. So first of all, let's write the equation for percent yield. Percent yield is actual yield divided by theoretical yield times 100%. So let's just feed the figures in. And you will get the answer 82.3%. But if we refer to the previous slide, earlier on the data that was given was in 2 significant figures. So actually we should round our answer to 2 significant figures. So that would be 82%.